All right, so let's now take a look at where we are in the course. For your lab number 4, it has been released since last Friday, and you want to maybe think about in perspective. Lab number 4 is going to be highly relevant to your programming test number 3. Let's take a look at the course calendar to see where we are. If you go there, let's review together. So we are now here, lecture 16. So there is no scheduled test tomorrow during your enroll lab session. However, I will attend both sessions tomorrow morning and the afternoon. So this is what I plan to do. So we're going to introduce the programming part for inheritance today, and also about the 2 keywords that you're supposed to know how to use for programming inheritance, which are required for lab number 4. So for tomorrow, I'm thinking I'm going to go over with you the in-class example about inheritance. I'll do that in the morning and the afternoon session. So I'll encourage you to really come and attend the demo, do the demo together, and ask me questions. I'm sure that's going to help you for the lab and the programming test later. I'll be there both the morning and the afternoon. Take your pick, like when you want to attend. And your written test number 2 will be next Wednesday, November 13th. So for tomorrow, by the end of the day, I'm going to give you the guide confirming the coverage for the test, and also give you some example questions to practice. But of course, your safest bet is to go over everything that's actually covered in the test. You can look forward to the guide. I'm going to give it to you tomorrow. And I spoke about the in-lab demo already tomorrow, hopefully to see many of you tomorrow. And then for your programming test number 2, I already handed all the submission to the TA. So I believe they started the grading process late last Friday. I am not exactly sure if I can get a result from them this Friday. I know it's a drop deadline. I'll try my best to see if I can push the TA to do so. But if I cannot, tentatively, I may have to say Monday next week. But I'll try. If I can get it earlier, I'll definitely get it earlier. But I'll keep you posted about the programming test 2 grading. All right, guys, any questions you want me to clarify about the course? All right. If no, let's now move on with the materials. And as usual, let's have some recap about what we said last Thursday. So last Thursday, we introduced the idea about aggregation versus composition. It's not a difficult idea. You just have to understand the terminology. And especially for aggregation composition, understand what's really container versus containee. It's kind of symmetric. Whenever you got some link at the runtime, for example, this guy over here, and with some sharing, immediately you got container versus containee. All right? And so these are the 2 principles for you to judge whether you should use aggregation or composition. We finished the discussion about aggregation last time. For today, I want to finish the last bit about composition, especially how we can do deep copy. That's important. Right? We'll get there. And we spoke about the modeling diagram. You're not required to really draw them in the written test or exam, but you're supposed to read them. Okay? You want to distinguish between empty diamond, which represent aggregation, versus solid diamond, which is composition. That's the easiest way to tell. And I also talk about if you're given a single aggregation relationship over here, how are you supposed to interpret that in English? I also spoke about it. You want to make sure you practice that before you take the test or the exam. And also the corresponding Java classes, that's also straightforward. Once you move to the Java world, it's really something we have been doing since forever. Right? And these 2 pages are the exercises assigned to you. I would suggest maybe at the latest, before your written test number 2, you should really get yourself familiar with tracing aggregation. It's nothing difficult. It's really something we have been doing since day 1 of the course. All right, and then this page is really important. Okay, I know it's tricky, but it's really something you want to get through. We spoke about whenever you got some dot notation, where on the right-hand side, you got some private attributes, or in general, private method. Let's say private attributes. Whether or not this line should compile depends on what's the type of the path expression before that. If the context path has the type that's the same as the class where you're writing this line, then it should compile. Otherwise, if the context path has a type, for example, y, that does not match where this line is written, for example, X versus Y, they should not compile. That's the principle. Of course, if you definitely want to review how we discussed 1 and 2 last Thursday about why this one should not compile and this one should compile. Once you understand those two, I suggest you try every one of them over here, both on the paper and also use Eclipse to tell you what the correct answer should be. In the written test, it might just be multiple choice of this kind of question. But in the exam, I'm going to ask you to justify why one line should compile, but the other one should not. You should really use this the same way I justify these lines on Thursday. So guys, any question you want to ask me about this one here? Or you just need more time to study? Okay. Maybe get them through. And these are important stuff. That's why I'm talking about it. And after discussing this last Thursday, we also spoke about the set of 3 exercises. Depending on where you are, it could be in the context of the student class, it could be in the course class, or it could be in the faculty class. Depending on where you are, the methods that you want to implement accordingly is going to be written differently for the dot notation. For example, let's say over here, we spoke about expression like this, right? So you want to review them as well. Let's say I'm now currently in the course class, right? That's why I can say this.prof, which refers to the prof. And now as soon as I see the prof, I know that I now can navigate to the faculty class right away. Now in the faculty class, I got get TE, because TE is actually some private attribute for which I assume there's a public accessor. Once I get TE, it's going to give me some array of courses. And then I want to go to some particular index I, which will give me course. And now I know that I got to navigate back to the course class. And then I say the title. So I want to get the title of the course, and etc. So this is the kind of navigation that you want to be familiar in OO, right? Depending on where you want to go, sometimes you might be able to access some private attributes. Sometimes you may not be able to. That's also something we discussed last time. Okay. All right. Any questions about this exercise over here? Of course, you got to practice, right? Okay. And then we spoke about composition. Okay. So the example that we used was about directory versus file. And if you so the first page over here, there's no concern about composition violation because there's only a single directory. You can see for this single directory here, we got 3 different files. Each file is exclusively owned by directory number 1. But things might get violated if we try to make a copy of the directory, right? So the shallow copy that we spoke about on the second page, that was the last example we did. Oh, and then we talk about copy constructor. Of course, the way to judge would be if the parameter type matches the current class, that would be a copy constructor. Typically just one parameter. Okay. So the shallow copy example that we spoke about, this one here would be a violation of composition because the way we define the copy constructor for directory that we spoke about last time, okay, just very quickly. You can see that there is one variable assignment here, just using equals. And the files over here is an array of files. So we're basically saying, in order to assign the value to this array, I'm just going to copy the address of the other array. I'm not creating new array. So the way to visualize it would be, so D1 array, D1.files is already pointing to here. Now, for D2.files, rather than creating a new one, that's not what I'm doing here. I'm just let it point to the same array here. Lots of sharing over here. So that's a violation of composition. Okay. For example, you can see if I change the name of f1.txt into maybe f4.txt, I'm changing the file for both D1 and D2 because it turns out they point to the same file. Right? So there's sharing going on, aliasing. What we want to do today is to see how we can implement the so-called deep copy, very deep copy at every level so that we can avoid sharing files, for example. And here is what you're going to see. In order to, just before that, let me say that first. In order for you to implement deep copy, what you will need is you're going to have copy constructor for almost every class that's involved. That's something we'll see. In this case, we need a copy constructor for directory. We also need a copy constructor for file. That's something we'll see in the new page. Question first.
So just to make sure, when you're saying violating composition, if that's the design principle that we're going for, is it the same way as preserving the property of composition? Because that's how they worded it in the lab documents. Is that?
Okay, sure. Yeah. So when I say preserve, I mean it's basically satisfied. So when I say preserve or satisfy, that means we are following it. Now, when I say violation, that means you have some sharing in the composition, so you're not following it. Yeah, just the wordings. Yeah. All right. All right, guys, that will be the end of the wrap up. And we're going to do some new thing today. Any questions? No? Okay, awesome. Let's now take a look at deep copy, and then we'll move on. Okay, this will be your deep copy. If you look at the slides, it will be slide number 26. You can see the code over there. And I'm going to go over with you and then trace it. I think this will be definitely important to trace it together. Okay. Now, I'm going to make it a little bit larger here. So now, for your file class, you can see we have one copy constructor already. So this is a copy constructor. This is already a copy constructor. And what it does is, given another file, I'm going to make a copy of it. And I'm simply going to create a new file object, and the name is just going to be a brand new string. Okay? We're going to visualize it in a moment. And then you can see that in the directory class, like from last time, we got two so-called overloaded, right? Whenever you talk about methods with the same name but different parameter lists, it's called overloading. So now we got the same constructor here. Of course, the name will be the same, but the parameter, one is string, the other one is directory. They're different. So that's why I said they're overloaded. So this guy here is not a copy constructor because you can see the type here is not directory. On the other hand, this constructor here is a copy constructor because directory. All right? So this one here, let me also make a note over here. This is just another copy constructor. And one thing we can see right away, even before tracing, you can see that there is the use of this keyword over here, but slightly different from how we talked about it earlier. So here, after this, if you immediately say opening parenthesis as if you're calling a method. So that one is to say, I want to call another constructor in the same class over here. How do I know it is this one it is calling? It's because I'm passing other than name. Other here is a directory. The name is going to give me some string. So I'm basically calling this version of the constructor taking a string. Okay, that's how I judge. I can make a note over here right away. So this one here is invoking another constructor in the directory class. All right, that's some syntax for you to pick up, which is not difficult. And then we also have a loop over here. All right, I'm going to trace it together with you in a moment. And the loop over here, one line to draw your attention right away. In the loop, for every iteration, we are trying to create a new file. And the way we create a new file is by making a copy from the SRC, which we're going to see how exactly it looks like. But this new file over here is a call to the copy constructor. All right? That's also something I would like to point out right away. So this one over here is invoking the copy constructor. Invoking the copy constructor from the file class, which is over here. All right? So these are the details you want to really pay attention to when you study the notes. This one, this one, this one. All right? And what we should do now is to trace it line by line. We don't really need to trace every iteration. Just one iteration will be enough. For the rest, I can just finish a diagram by showing you. Just the first iteration will be important. All right, let's now take a look. The way we're going to trace it is by following the test case over here. Okay, let's make it here. And this part over here about initializing and setting up D1 will be just the same as what we spoke about on Thursday last week. So this one here basically set up D1 over here with an array D1.files, and we got 3 files added. We got 1, 2, and 3. This one, no surprise, so we don't need to repeat. Now the idea would be we want to make a copy of the directory objects, and somehow we want to call the copy D2. The way we do it is by this line. Okay, look at this line very carefully over here. That's the line we are writing. We say D2 should be a new object by calling the copy constructor of directory, and then we're passing D1. All right? And when we trace to the directory copy constructor over here, let's make sure the context is clear. So you can see D1 over here, and we got other over here. So whenever we talk about other, we are really talking about D1. Okay? Or you can think about the D1 here is the other. And to really understand this 100%, you want to think about call by value, right? Which we also spoke about last week. Okay? For that part, I'll let you do the connection. Alrighty. Let's now try to trace this copy constructor over here line by line. Okay? The first one. The first one here is going to invoke the other constructor in the same class, which is over here. That one there is just going to other, as we said, is actually D1. We're going to create a new file, sorry, a new directory with just the same name as D1. Okay, so that means we're going to have D2 over here. That one is going to point to the new directory objects. And then, oh, I beg your pardon, I traced to the wrong thing. Forget about what I just said in the last 20 seconds. Let me do it again. I do apologize. So let me say it again. So when we trace the very first line here, this one here is basically calling this one here. It's not a copy constructor. This one just another regular constructor that's overloaded. So other.name will be D1.name, which is D. All right? So when we call that, the one we should really trace instead is not here. Okay? It should be over here. Okay? This one here. And that one here is pretty straightforward. We're just going to copy the name over and create the array. Okay? Let's visualize that right away. So that means the D2 is going to point to this directory objects, and then the name is going to be a new string, D. Look at that. There's no sharing of the string. Just a new string. And then the files is going to be just brand new file array, 100. So this one here is going to be an array of size 100. So we go from 0, 1, 2, all the way to 99. And NOF in the beginning is going to be 0. Notice one thing right away. You can see in this new version for the deep copy here, you can see at the files array level, we create a new array. Versus if we go back to the shallow copy from last week, the files point to the same array. We can see some difference already. All right? That's something you want to compare yourself to. All right, so what this line does is we set up the D2 directory rather simple, right? Just like that. And every slot here is going to be null. I'm just going to omit that, right? Every slot in the beginning. And now let's try to trace this loop over here. This loop. Let's figure out how many iterations we need for this loop. It depends on what's other.nof. Depending on how many files are in D1, then we're going to copy this many times. So other would be D1. D1.nof is actually 3. That means the first iteration, copy this file. Second iteration, copy this file, and etc. Okay. So what you want to really put aside is some notes over here. So other.nof, we know that is 3. So for the loop counter I, it's going to be 0, 1, and 2 for 3 iterations. Let's just trace just the first one. That'll be enough. For the first iteration, the first line here, we're going to create some reference called SRC for source. That one there is simply going to be d1.files at index 0. Okay? So for the first iteration, src is assigned to d1.files at index 0. Okay? That means src is pointing to this file over here. So there's an aliasing, but it's only temporary. So once we got the source file over here, we're going to the second line. The second line here, we're going to create another new file, nf. This one here is going to be a brand new object because we're having a new keyword here. And the way we create a brand new file is by calling the copy constructor of the file class. All right? So now we say new file and then from the source. And source is pointing to this particular D1 file. We want to make a deep copy of it. Okay? And if you try to trace this one, which is not difficult, imagine that you are saying step into at this point. If you say step into, you're going to step into this copy constructor here. That one there, pretty simple. You're just going to create a file object, and then the name will just be other.name. What's the other? Other is basically this file over here. Okay? And the name will be f1.txt. So what we do is we basically create a new file over here, separate. Think about it's like an nf. And then it's of type file. And then we have some name here. That one there is going to be f1.txt. And notice that we did say here, new string. All right? That's why you can see f1.txt is also a new string over here. The final line is this. We say this.add file. So we are saying that now for D2, we're going to add to index 0 this file and update this from 0 to 1. I'm not tracing that exactly 100%. That'll be too tedious, but that's something we have been doing since the beginning of the course. So I would say you definitely also want to try doing this yourself too. All right? So after the first iteration, what we have achieved is this. We got D2.files at index 0 is pointing to a brand new separate deep copy of this file, which is a copy of this. They have nothing to do with each other. All right, so now let me finish the diagram. But if you want to keep tracing, you got to go for when I is equal to 1 and I is equal to 2. In that way, this 0 will be 1 or it can be 2, etc. Right? That's something you can practice. So after the second iteration, we are actually going to create just another file over here. So f, and the name will be a copy of this, which will be f2.txt. f2.txt, and then that one there is going to be added to index 1. And then at the same time, we got to update the counter from 1 to 2. All right, the final iteration when I is equal to 2. So we just got another file over here. And the name will be a copy of this one here. So that will be f3.txt. And then we're going to add it to index 2. That one there is going to be something like this. All right, and then finally, update the counter from 2 to 3. So that's the whole process of executing the deep, like a copy constructor for deep copy. What you got to notice in the big picture is, in order to trace the copy constructor for directory, you have to also, number one, trace the overloaded version of the constructor in the same class. Also, you got to trace the copy constructor of another class, in this case, file. That's what you got to do, right, when you do the practice. Is this preserving composition? Yes, because if you look at the JUnit test, or I can just illustrate to you, you can see files and files versus files, different array. That's good. And you can see files at index 0 here. D1.files at index 0, this object and this object here, they are completely different. Meaning that if I modify the name of this file to something else, does it impact this file here? No, it doesn't. So that's why it's composition. Okay. Let me just write down one thing here so you will see. If you try d1.files at index 0, it's not the same as address-wise. d2.files at index 0. They are not the same. So this is how we preserve the composition. All right. All right, guys, any question about this? If you get a big picture about the tracing here, that's great, but details will have to be filled out by you. Okay? But hopefully you see what's going on here, at least. All right, if you don't have question, I have one question for you. Okay, go ahead.
One small thing. When it comes to the copy control, is there any benefit to actually preparing a new string?
Yes. I would say, okay, your classmate asked a very good question here. Is this new string over here really necessary? Okay. Technically speaking, for string, which is so-called immutable in Java, it's not so necessary. But somehow I don't really want to get to the discussion about what does it really mean for a class to be immutable. It's not really a part of my plan for this course. So I would say for now, whenever you're implementing your deep copy constructor, whenever you want to duplicate some object, always remember just create a brand new object. For string, it could be an exception. You don't really need. But I would say just easier for you to remember. Mm-hmm. Yeah. All right, any follow-up before I ask a question? Go ahead.
So does that mean that if you want to do composition
Mm-hmm.
for one of the classes, then that class has multiple classes inside, we also need a copy constructor for every single class?
Yes, you can say that. Yep. So think about like a container idea. So let's say in general, if you have a class that's supposed to be a container, and then you refer to maybe one attribute type, which is referring to another class. So if you want to implement a deep copy constructor for this, of course, you need a deep copy constructor for other classes as well. Yes, that's a good summary. Yes, in general. Yes.
So just to make sure, even though that string is not a primitive type, it kind of acts like one in that sense?
Say that again, sorry.
Even though a string isn't a primitive type, it kind of acts like one where it copies the content but not the object.
I would say it may not be so advisable to understand in this way. Okay, string is a reference type. Don't get it confused. And string is immutable. There's a very special phenomenon, which I don't really want to get to confusing everybody. I would say treat a string class like every other reference class. Okay, and then whenever you want to make a deep copy, you just create a new string. That's okay. That's just easier for you to remember. Maybe outside the scope of this class, you may research into what immutable class really means. Then that might tell you it may not be necessary for you to do that. Mm-hmm. You rather overdo as opposed to underdo, right? When you implement composition. All right, I do have one question for you. Okay, the question goes as follows. We talk about deep copy over here, and I'm going to introduce another version over here. So the deep copy we just spoke about, and this will be an alternative version of the copy constructor, which is over here. And this one looks very similar to what we said earlier, but let me show you the difference. And we talk about whether or not it should be appropriate. Okay, here. So if you recall, the copy constructor for directory here, we got a source, and we call the copy constructor for the file. But now, let's say in this new version here, I delete this line. And then I say, rather than adding the file, adding a deep copy of the new file into the directory, I'm just adding source. All right? And the source is basically pointing to just the original file over here, rather than adding the new deep copy. That's basically the difference between these two versions. The question is, for this new version here, is composition still preserved? Or is it violated? If you believe it is violated, how exactly is it violated? If you say it's violated, you got to point to me where the sharing really occurs. Anyone? Go ahead, please.
It's violated. The way I think about it is that if you change the file name from one of the arrays, in the other array, the file name will also be changed.
Because somehow the same file is being shared.
Yes.
Okay, I agree. That's a very good answer, but we're going to see exactly how this sharing ever happens. I think your classmate said exactly right. So in this case, we do have some sharing, not at the array level, but at the file level. But let's see exactly how that occurs. All right, let's now try to trace this right away. Okay, when you try to create another directory, right? So this one will be the same as before. So I got D2, and then I got a name will be D, and also an array. So the array will still be a new array. That one doesn't change. 0, 1, and 2, all the way to 99, and then 0. All good. And then when you go to the first iteration, now I still got my source. So src is pointing to this file over here. Okay? And the pink line here was deleted. And when I'm adding to D2, to index 0, I'm not adding the deep copy anymore. I'm just adding the reference of source. That one is basically doing the following. Index 0 is now going to point to just the same file. So obviously, when you see the diagram, sharing is happening. So what classmate said was right. If you try to change the file name from F1 into F4, for example, in that way, F4 is going to impact just not only just D1, but also D2. Because they all boil down into the same file. Okay, so it is violated. And let me write down some assertion for you to try. So here, after this, if you try, let's say D1 dot files not equal to D2 dot files. This one is good. So we are still talking about two different arrays. As far as the array level is concerned, we are good. On the other hand, if you try D2 dot files at index 0, if you say equals, I'm going to put it above D1 dot files at index 0. This will also give you true. That one is sharing, aliasing, right? Because D2 dot files 0 is pointing to this file here. D1 dot files at index 0, D1 dot files at index 0 is pointing to this file. So we are talking about the same file. So the address will be the same. So that one is a violation of composition. So this is the violation of composition. Yeah, try to see the difference between the two versions I'm providing to you and think about it. All right, any question? So that will be the last example I want to speak about for the file directory example, right? So now you have seen different versions, and you can also try to apply to your either Java development or when you get prepared for the test. All right, no question then. I just got a few more slides to go over, and then we're done with the aggregation composition. All right, the next slide here will be slide 30. So this one here just summarizes about the different terminology, right? The definition for aggregation, composition, everything has been covered. So I'll leave that to you when you study. And so some example here. Sometimes maybe part of your system should be implemented using aggregation. Another part should be implemented using composition. Maybe, let's see. Let's talk about the Williams Small Center Labs workstation. So we say that each workstation has their own CPU, monitor, and keyboard. So no two workstations should share the same keyboard. Should this be aggregation or composition? Composition, right? That makes sense. No sharing. On the other hand, what can be shared between workstation? Network, right? All of them got connected to the same network. All right, and then, so this will be some diagram for you to understand, right? Let me show to you. You can see this is workstation number 1, workstation number 2, and workstation number 3. And for this part of the system, you can see that each workstation has their own keyboard, doesn't share, also has their own CPU, also they don't share, and etc. So this part here is composition. So for this part over here, it should be implemented using composition. Whereas you can see this part here about the network. They all point to the same objects for the network. So that will be aggregation, aliasing. For example, if there's any network failure on this network here, it's going to impact every workstation because they share, right? That's just one easy example to show to you. Part of your system might need composition. Part of your system might need aggregation. There's no clear cut about whether your system should be completely aggregation or completely composition, right? It depends. So there's a final example before we move on to inheritance. All right, so now let's consider this example here. Let's say we talk about book, right? So let's say every book that's published has an author. So let's consider the author attributes of the book. So maybe there is one class called author. And we say that every author may publish more than one book. Yeah, that makes sense. And now, should we implement the author as an aggregation or composition? Meaning that, should we allow the author of a book to be shared or not be shared? That's the question. It's more like a modeling decision you have to make, rather than being told exactly what you want to do, right? Any thoughts based on your understanding so far about aggregation versus composition? Which one do you think makes more sense? Go ahead. Author may got multiple books, but when you say aggregation, you're saying that for if I got, let's say, book number 1, 2, and 3, they have the same author. You mean they share the same author? Okay, sure. That makes some sense to me. Anybody else? Yeah, books have different author, but just mean they are different, right? But what if, let's say, an author writes 2 books? Should those 2 books share the same author? That's the question then. All right? All right, so this question here is very interesting because there's no right or wrong answer. It depends on what scenario you're thinking about. So when I talk about book, it could be electronic book, or it could be hard copy book. So imagine that, let's say, if I got a hard copy book over here, I got the author name printed over here. Let's say I got 2 books. The same author got printed twice in 2 hard copies. If I change the author name on one of the hard copies, is it going to change the other one? Not really. Right? So that's one scenario. Another scenario would be, let's say I got ebook on the website. So there is a hyperlink for you to click on to the author page. If I modify the author's page information, should that be reflected on every book the author publishes? It should. So there are different scenarios you want to think about. So I kind of included them here. So it could be aggregation, in which case you can think about there is an author page over here. Whenever you modify any information there, the hyperlink is going to make sure the corresponding book is going to be impacted. On the other hand, if you got physical copies of books, in that way, if you modify something on one book, it doesn't really modify the other one. Right? So it depends on which scenario you want to implement or model. All right. So the lesson we learned over here is if you're told directly about how you should implement either aggregation composition, that's easy. But if you have to make a modeling decision, it's usually a bit challenging. It's kind of beyond the scope of this course because usually that may not be a right or wrong answer. That's more like a 3311. You have to make a decision. But just want to give you some feel. All right. If any questions about this? And that will be just a suggestion for extra practice. So the file directory, course, students, example that we did in this slide, I didn't really provide with you the source code. If you're interested in some extra exercise, I would suggest you try to reproduce them on Eclipse and try to play with them using debugger and breakpoint, if you want to. Any question before we move on? Alrighty, so if no question here, I'm going to close this lecture here. And finally, we can get to inheritance. It's a big lecture. So today, we're going to do some basic stuff. We still got 40 minutes or so let's do a little bit first, and then we can take a short break. A little bit. So for the inheritance lecture, we're going to understand some alternative design. This is something I would like to talk about today. Before we can really appreciate inheritance, let's now think about what if we have no knowledge about inheritance? How can we solve problems already? How can we solve the problem without inheritance, and then we compare that solution with the solution with inheritance? Right? That's something I want to do today. And then you're going to use the inheritance for code reuse. This is something I want to show you in more detail tomorrow in the in-lab demo. Okay? That's something I want to do more Eclipse hands-on tomorrow. And then we're going to come back here for static type, dynamic types, and also typecasting. That's something we spoke about a little bit, during the equals lecture, but now we're going to tell you the whole story. Okay? We'll get there. And once we have done all the basic foundation for code reuse, static type, dynamic type, we're going to talk about something called polymorphism and dynamic binding. So these two are the most important things to understand about inheritance. It's not just about understanding the super keyword or extends keyword, not just that. It's more than that, inheritance. So we're going to spend most of the time talking about polymorphism and dynamic binding. And typecasting, that's also to come. All right, so this text over here is the design exercise I kind of encourage you guys to try. If you haven't tried, that's okay, never too late. You may still try beyond the class today. But for now, why don't I give you guys about a minute just to read it through very quickly, at least understand what are the terms that's being used in this example. And then I'll jump right in to the two possible solutions to this without inheritance. Take 1 minute. Just recognize the key terms that you believe that's important. Okay, just one more moment. Okay. Alrighty. Okay. So this is actually a very typical problem that can be solved by inheritance, but it's also solvable by, for example, let's say today you're not really using Java. You're using a language that does not support any OO. Let's say C. C does not support any OO. How would you do it without inheritance? So I'm going to present to you two possible solutions, but we're going to realize both of them can be criticized by some well-defined design principle, which I'm going to show to you. Okay? Let's now try to help you identify the key phrases or key terms in this problem description. So we need some kind of idea about student management system, which is going to store maybe an array of students. And we got two kinds of students, either resident versus non-resident. Each one of them, these two kinds of students share something in common, and also they got something that's unique to themselves. But each one of them got name and registered courses. That's what they share in common. On the other hand, for example, when we want to calculate the tuition for resident students, we have to somehow take into account the premium rates. On the other hand, if we want to calculate the tuition for non-resident students, in that case, you want to calculate using discount rate. It's going to be different behavior when you actually want to implement the different kinds of students for getting tuition. this will be something we want to solve today without using inheritance. And I hopefully will also get enough time to show you a little bit how to program the inheritance solution as well. Okay, let's see one thing at a time. All right, for those of you who actually try this design exercise over here, I think more or less you're going to fall into one or two of the possibilities. I'm going to give you both. And these two possibilities without using inheritance will also give us a lesson about what design may be considered as bad and what design may be considered as good. Right? Design number one. Here. So we got only one student class. We don't really have resident students class or non-resident student class. Just one class called students. And in the student class over here, we got an array of courses, also the number of courses. That one's easy. The most critical attribute you want to take a look at will be this one here, kind. I forgot, apparently. You guys should have told me earlier. Too shy, all right? Please, let me know earlier next time. All right, let me say that again. So we have the student class, only a single one. And then we got an array of courses, also got a number of courses over here. Okay? The most critical attributes will be the kind over here. And it's integer. Let's make the following assumption. Okay? When I say the kind is equal to 1, that means it's resident students. Okay? And when it is equal to 0, okay, how about 2? Then it's going to be non-resident students, let's say. Using integer as opposed to Boolean has its advantage. Because if you only use a Boolean flag, like a true or false, you can only encode 2 kinds of students. But if you use integer, you can encode so many kinds. Potentially, that's good. And one thing to note, if the kind happens to be resident students, you know that it's going to be applicable for premium rates. On the other hand, if the kind happen to be non-resident students, it's going to be applicable for discount rate. Okay, I'm kind of putting both attributes in the same class. All right, you can see we got premium rates, we got discount rate as well. And it is so important when you first create a student object, you gotta specify what kind of student this is. Let me show you. It could be that here, I might say, students, resident students will be new students. And then for resident student, it's going to be 1. What about non-resident students? I will do here. I still got a student object here to be created. I call that NRS. New students. And this time it's going to be 2. I'm basically just creating student objects at the runtime. However, depending on what attributes kind is going to store, it could be 1, it could be 2. Everything else is going to work accordingly. All right? So far, so good. And now at least you understand how the kind is supposed to be initialized, right, from the constructor. And for get tuition and get and also register, let's now say the way we get a tuition for these 2 kind of student will be different, and also the way we register will also be different. How should we program the methods accordingly? Here is the trick. Okay, let's say for get tuition. Number 1, we calculate the base amount. So tuition initially 0, and go over all the courses for this particular students, and then calculate the base amount. Let's say if they are currently enrolled in 5 courses, add up the fees for the 5 courses. That'll be the base amount. So this one here will be the base amount. The base amount. And then we are saying that now it depends on whether the kind of the students is either equal to 1 or 2. We're going to do differently. For example, let's say this. For this RS, because the kind is actually equal to 1, so that means when I invoke get tuition on RS, I'm going to evaluate this branch over here to be true. So I'm going to apply premium rates. On the other hand, if I try to invoke get tuition on this particular students, which will be kind number 2. In that way, kind equals 1 is not true, so I bypass. And kind equals 2 is going to be true, so I'm going to apply discount rate. Right? That's how I get things to work. Kind of clever, but we'll see. Okay. And something very similar. Let's say for the register method, we want to say for resident students, we can allow them to register up to 6 courses because they live on campus, for example. But for non-resident students, because they live outside the campus, they are only allowed to take up to 4, let's say. Okay? So we basically doing something very similar when the kind is equal to 1 versus kind is equal to 2. The maximum allowance will be set either to 6 or 4 accordingly. And then this part over here is to say, if the current number of courses has already reached the maximum, in that way we cannot register anymore. In that way we can signal some error. It could be some exception throwing. And then otherwise, if they haven't reached the maximum just yet, we can just add a course into their registration list. So what you really want to pay attention to are the orange one over here. Depending on what the attribute value for kind is, which can be 1 or 2, the methods is going to behave accordingly. That's the essence for this design here. And one remark I want to make, okay? If you try to simulate OO in a non-OO language like C, this will be more or less what you have to do. Okay. This is just a remark. That's a little bit advanced, but I just want to mention to you. This is how to simulate OO in a non-OO language, like C. All right. All right. If no further question about this design, let's criticize on it. And I'll just use this example as a way to introduce 2 design principles. Okay. One is called cohesion. The other one is called single choice principle. So these 2 are the very practical design practices principle you want to learn. Okay? Number 1, cohesion. What's really cohesion? What does it really mean when your class is cohesive? Here is a simple definition. Cohesion simply means the attributes and methods in a class, in a single class, follow a unifying theme. This should be consistent, unifying theme, all of them. Now, based on this definition here, I claim that the first design is not cohesive. Can anybody see why? If I say a design is not cohesive, I'm claiming that somehow you put unrelated stuff in the same class. What are they? If you look at the student class, what unrelated stuff am I putting here in the same class? Still hard to see? Yeah, go ahead. Yeah, you. Oh, that's pretty good. Okay. So you can see here, premium rate and discount rate. These 2 are unrelated because the premium rates is only applicable to resident students. Only apply to resident students. On the other hand, the discount rate only apply to non-resident students. They are not related to each other. So you shouldn't put it in the same class. If you want to fix it, you separate them. That's one principle here. All right, cohesion is not difficult. You just want to see. That's also a good way for you to maybe go back to your previous lab. When you introduce new attributes in your class, you want to think about, is the new attribute I'm introducing really relevant to the current class? Right? That's cohesion. Oh, sorry. That's the first principle. Another one is called single choice principle. Okay? Single choice principle in some way has to do with the helper method that we talked about earlier. Okay? I claim that this first design violates the single choice principle because I got code smell. I got duplicates of code. What kind of duplicates do I have in this class over here? Can anybody tell me? I already did it actually in the earlier annotation. But let's say this is the clean page. What kind of code duplicate do I have? That's important to observe, yeah?
Checking the type.
That's exactly right, okay? This design here, the biggest drawback is almost for every method here, because you're encoding the kind as a value for the attributes. In order to let the method behave properly, you cannot avoid by checking every method the kind of students you have. So the duplicate I have is number 1, here. Number 2, and here. Oh, sorry, and here. So I got 2 methods here. I repeat the if structure 2 times. If I got 10 methods here, I got to repeat 10 times. I got 100 methods here. I got to repeat the if structure 100 times. Bad. And single choice principle goes a little bit further. So what will be the consequence if you got code duplicate? Now, if I want to introduce a new change to my code, single choice principle will be preserved if there's only a single place I need to modify the code. Let's say, for example, I want to introduce a new kind of students. Let's say here, a new kind of students, right? Let's say international students. Let's say international students. It's a new kind. And we already use up 1 and 2, right? So why don't we say a new kind, international will be just 3. All right? So now, I know that in order to handle the international students well, I need to modify somehow get tuition and register. Apparently, I'm already talking about, I'm modifying 2 places here already, not just a single place. Where exactly should I modify? Okay, anybody see? Now I got a new kind, which is number 3. What should I do in order to update my method to handle this new kind of student properly? Where should I go? Yeah, go ahead. Yeah. Oh, I need to add else if, for example, I need to add it here to say else if this kind equals 3, and then do something accordingly. You said that the only place I got to go? Yeah, for every method. Now I got 2 methods, I got to do it 2 times. All right, so I got to do that here as well. And else if. And you can say this kind equals 3, and then I'm going to do something accordingly. You can see I need to repeat this one here and this one here because I got this many methods to update. All right, so single choice principle tells you as follows. If you got duplicates in your code, that most likely imply if you want to somehow modify some relevant change, you have to go to multiple places to modify the change. Okay. So cohesion and single choice principle, right? It's not really like a coding problem. We are trying to judge the design, which is one level higher, which I really hope you guys can pick up the idea. All right, recap. The first design doesn't seem to be too bad to understand programmatically. Just understand this attribute here and the if statement that you have to write. However, from the design point of view, it's pretty bad. It violates cohesion, It also violates single choice principle. That's design number 1. And we're going to take a short break. So when I come back from the break, I'm going to give you a second design. Still no inheritance. But I'm going to improve one of the criteria. All right? So let's now pause the recording and take attendance. How about that? All right, so before the break, we spoke about the first design. And now let's talk about second design. And so second design in some ways is easier to understand. So when I present a design, I will suggest you guys think about which design principle, cohesion, single choice principle, which one does it violate and which one does it preserve? Okay, let's now take a look. All right, no inheritance. So we got one class called resident students. And so I'm going to distinguish between resident students and non-resident students into two classes. That's some immediate difference you can see right away between the two designs. So resident student got name, courses, number of courses. We got premium rates. And premium rate only applies to resident students. So I only put it in the resident student class, only here. Okay? And then I got resident student constructor, where I'm going to initialize the name and also initialize the course array. Easy. And let's say for register, for simplicity, let's say there is no restriction just yet. Okay? So just register, like add course. Also, we got get tuition. So this part of the code calculates the base amount. At the end, we just going to apply the premium rates. So you can see right away, in the resident students class, is it cohesive? The reason that the earlier design was not cohesive, if you recall, let me remind you very quickly. The earlier design over here, it was not cohesive because we put premium rate and discount rate in the same class. But now, what we did was, in resident students class, we only put premium rates. Whereas in another class, non-resident student class, you can see we only put discount rate, but not the other one. This is cohesive. Would you agree? Right? That's something you can definitely compare, right? I'm just telling you right away. You do need some time to digest the idea. So we got resident students, we got non-resident students. For the non-resident student, you can see this part here is also common. We got name, we got courses, we got number of courses. Discount rate is unique to non-resident students. The same constructed definition here. And also we got the register, which for now is unconditional. We also got get tuition, calculate the base amount. This part here is the same as resident students. And we're just going to apply differently discount rate at the end. So these are the two classes for the second design. I already argue that we actually satisfy cohesion, which is good. It's already an improvement from the first design. Does it satisfy single choice principle? The way to judge is, does it contain duplicates? Okay.
I would say yes, because if you wanted to change how the base equation is calculated, you have to change the whole stuff.
That's very good. You got even one step ahead. That's very nice. So what your classmate said was absolutely true. If, for example, I want to modify the way, for example, we calculate the base amount for the tuition, not only that we get to modify the version in non-resident students, but also we need to modify the version for resident student as well. Not single place. Absolutely. Question?
No, I would also like to add that if another type of student comes up, then you need to build a new class.
Yeah, a new class, which means for the new student class, you also need to repeat, for example, the name, courses, NOC, and also all here. You're going to repeat. Very good. Both valid answer. And one more thing to say. If you look at the color hints over here, I got resident student here, and if you compare these two pieces of code, the only thing they share in common is not highlighted. You can see what's highlighted here is the difference. What's not highlighted, for example, this part over here, this part over here, and this part over here, is all repeated between the two classes. Okay, quick recap. Design number 1 before the break, it violates cohesion and single choice principle. Design number 2, which we have just seen, that one improves on the cohesion, but still suffer very badly from single choice principle. Lots of duplicates. And what we want to do is ultimately use inheritance solution, which is going to satisfy both cohesion and single choice principle. All right, you can see the progression here. All right, for the second design, pretty easy. I don't need to trouble you too much. You can also go over them. The only thing I will assign to you as exercise will be as follows. If you look at this class over here and this class over here, and then there is some tester over here, you can just try to, you don't really need to even draw anything. I got some diagram here for you to start with. Just look at each line over here. Just convince yourself how it works, right, at the runtime. This is something that we did in the earlier lecture. So no inheritance just yet. Okay, this will be exercise for you. So what I will do now, as the final part of today's lecture, let's now learn some inheritance. Okay? And for the inheritance, so this part over here from slide number 7, this will be something I would like to do as a hands-on, maybe together with you tomorrow in the lab. So I encourage you to come so you can see exactly how things can be programmed in the inheritance. Okay, what I want to do now is jump a little bit. I'll come back here on Thursday. Okay, so we go directly to, this is something I'll cover on Thursday, don't worry. I want to go directly to the syntax for inheritance, which would be slide, there we go, 23, okay? So this will be the ultimate solution that we want to do. We're going to have still resident students. We still have non-resident students. But here's the difference. To really avoid code duplicates, we are only going to put whatever that's unique to resident students in this class. Whatever that's unique to non-resident students, we're going to put it in this class. For example, premium rates versus discount rate. Anything that's going to be that used to be repeated between these two classes, they should be factored out into the so-called superclass students. And in order to do that, we got to use the inheritance keyword called extends. So this will be the new keyword you have to learn in order to program inheritance. Let me repeat. We still got resident students, we still got non-resident students, but what's difference is all the duplicates will be removed by factoring out the common parts between these two classes onto the superclass. That's something we'll see. Okay? Let's now take a look at the classes. Okay? Right, you can also see the slide, but let me just not directly go over with you about what's happening here. So we got 3 classes. We got students, we got resident students, we also got non-resident students. Okay? Number 1, let's learn the first keyword, extends. Extends over here. So when you say a class extends another class, that means the resident student class on the left-hand side is going to inherit all attributes and methods from the student class on the right-hand side. All right, that's the number 1. Whenever you see the extend keyword, you have to know the left-hand side is going to extend by inheriting everything from the right-hand side. But let's not worry too much about private attribute just yet. That's something I will clarify on Thursday. But for now, let's just say everything. That's good enough for now. All right, so terminology. So in this case, the student class, which is being extended, is called a parent class. Okay, so here is called a parent class. It's called the parents or the superclass. Symmetrically, the resident students over here that extends the students is called the child class or subclass. So I'm hoping that by Thursday's lecture, at least you're very clear about whenever we got some extend keyword, which class should be called the child or subclass, and which class should be called the parent or superclass. Get that straight first. We're going to use that terminology even more later. Similarly, you can see the non-resident students over here is a child or subclass. extends the same student class, which is the parent or superclass. So we can also say that because these two classes have the same parent class, right? We can say they have the same parent class, okay? You can see, okay? You can see the extend keyword over here. You can say the resident students and non-resident students have the same parent class, or superclass if you like, the same. Every class can have only one, at most one, superclass. Okay? That's something we'll cover a little bit later. Let's move on a little bit more. So that's the first keyword you want to learn. The second keyword is the super keyword. That'll be it, super. And I'm demonstrating here 2 usages of the super. Let me do that very quickly. I will recap again, go deeper on Thursday. The first instance here is the super here. The second instance is the super over here. Let's look at syntactically what's the difference. For the first one, after the super, you got opening parentheses and also closing parentheses right away. Whenever you see the usage of super like this, that means you're calling the constructor defined in your superclass. Constructor call. Okay? This is invoking constructor at the superclass. So now in this case, we are really talking about invoking the student class constructor over here. So I'm going to make a note connection here. So the super over here, sorry, just got disconnected. Give me one moment. There we go. There we go. This one over here is over here. Okay? So the super keyword over here is really referring to that parent class constructor. Okay? Question? Yes, correct. Exactly. So let's say if you got more than one parameters for the constructor here, for example, let's say here if you got name, maybe integer, another attribute, for example, another parameter. The way to call that here would be name, comma, another input, and closing parentheses. Yes, you have to. Yeah, it's just like calling a method, basically. All right, I got about 3 minutes. Let me illustrate very quickly the other super keyword. So these 2 keywords will be enough for you to make some good progress on your lab number 4. Okay, and I'll speak way more on Thursday. The second usage over here, I'm also using super. But now super got dot afterwards. All right? This tells me I'm basically calling some method that's defined at a superclass level. Not constructor, anything but a constructor. I'll write it down and then make some connection and we should be okay. So this super keyword over here, you can see we got some dot immediately after. So put a star here. Invoke method define at the superclass. So in this case, let's watch very carefully. So since with a super dot get tuition, that tells me in order for me to define the get tuition over here, part number 1, I need to call the super version of the get tuition, which is over here. That one there is going to return back to me the base amount. Afterwards, I'm going to apply the premium rates to calculate the get tuition for resident students. Symmetrically, when I say super the get tuition over here, I'm going to call the super version of the get tuition, which is, again, this version here. That's in the parent class. That one calculate for me the base amount. And once I got a base amount, in order to return for non-resident student tuition, I need to apply discount rate as opposed to premium rate. So before Thursday, this is what I want you to do. Review very carefully the way we define the Java code on this single page, which put all the 3 classes together. Really convince yourself there's really no code duplicates over here. And then I'm going to recap on Thursday again. All right. Thank you so much. I'll see you tomorrow in the lab session. Okay.